Hello everyone, it is Araya, and welcome back to Project Pixel, otherwise known as Let's Make a Game, with you guys on YouTube. Last time, episode 0, we kind of just set up a project in our Git repository and just, some basics talking about what we're doing. Today we're going to actually start making the actual game. I want to preface this with a bit of a disclaimer. This series, I want to be relatively beginner-friendly, but if you've never programmed before or you've never used GameMaker before, it might be a little bit difficult for you. In the description, I have linked a little bit of a walkthrough of GameMaker. It's a little bit outdated, but most of it will still be the same, and you'll see the little various differences that, should be pretty easy to catch on. And also a little bit of a short tutorial series, just kind of introducing you to GML, or GML code, I suppose now is what it's called, which is the GameMaker coding language. Again, some small differences I'll explain when we get to them, but because there are old videos, but they should mostly be very held up. If you have never done GameMaker before, however you are an experienced programmer or know some knowledge of programming from like Python or Java or C++ or some other language, then it should be a lot easier to just kind of jump into this. But a little bit of familiarity with GameMaker would be great, and a little bit of familiarity with programming would be great. I'm still going to walk you through everything that I'm doing, but I might not be able to give the best explanations for some of the more simpler things that I take for granted as a programmer. With that being said, we can go ahead and get started. The first thing we want to do is mess around with some of our options. So let's go ahead and go to Game Options here and hit Main. Now, what you're going to see up here is this is the amount of frames per second your game runs at. The default 60. Let's leave it at 60. Even if you want your game to be like less fluid or whatever, you can leave it at 60 and you can handle all this stuff on your own. It is good to keep this at 60 because this will affect how often your game logic runs as well. It's just kind of best to keep it that way for now. If you go over to platform settings to Windows or Mac OS, if you are on Mac, you want to change this display name to the name of your game, so Project Pixel, for example. The rest we're not going to worry about for now. We'll probably get to eventually. And then for graphics, we will uncheck display cursor because we don't want our cursor to display when the game is running. Mac OS, you could do the same thing since eventually I'll be exporting this. The important thing is to do the one that you are running on. And also, Mac for some reason checks interpolate colors between pixels by default. We want to turn that off. Go ahead and hit OK to both of those, and OK to that. One more thing to mention is that everyone has a different coding style, and I will be using my coding style in this, and you'll see a lot of the little idiosyncrasies that I do in coding. You don't have to stick word for word verbatim what I put, but it might be easiest to stick with that if you're newer. But the important thing with programming is just pick a style and stick to it. All right, the first thing we're going to do is we're going to go to the scripts folder here. We're going to hit right-click, and we're going to hit create, and we're going to hit script. And then it's going to give us a little prompt, which is going to ask us if we want to do a code or visual. We're going to go with code. Visual's cool, but unfortunately it's not flexible enough for us to use for this project. It's pretty good for beginners if you want to mess around with it, but the problem with visual is not a whole lot can be like transferred over to code once you make that jump. So it's kind of easier to learn code from the get-go if you're doing that. So I'm going to hit code, I'm going to hit don't ask again for this project, and hit OK. So, if you notice, your script assets have changed for version 2.3. So if you watched the video in the description, or you haven't used GameMaker for a while, this is an important change. So how scripts used to work was I'd call this like my custom function, and then whatever you put in here runs when you type in my custom function, like that. That's how scripts used to work. But scripts are a lot better now, but they are a little bit different. So if you're doing like a script like my custom function, you have to actually define function my custom function, just like this, right? Custom function, just like that. There we go. And now I've got a function. We can call it from somewhere else, right? And if we have an argument, something we want to pass through, we can say arg0, and then we can be like, oh, show debug message, arg0. Show debug message is just a function that will output whatever's in here to the console, so you can see it, debug messages. And there's a function, right? And the cool thing about this is you can actually change this, the name of this file to anything you want, and you can still use this my custom function, and you can have more than one function in the same file. So that's kind of the main change here. you can have more than one function in a file. But we're actually going to be using a different feature here for this little script here. We're going to actually rename the script to macros in all caps. So what a macro is, if you're not aware, is it's kind of like a variable that never changes, but you can use it throughout your entire code, right? So for example, if I had a macro bump viscosity, it's spelled like that, and I want it to be 10. That's how you do it, by the way. Is, no equal sign or semicolon. It's just macro, the macro you want, and the value you can have. And you can have this be anything. You can even have this be like 10 minus the square root of 2, or you can have it reference a different variable or different macro, or whatever you want. But yeah, and the macro turns red, and now you can use it anywhere in your code. You can say like, show debug message, bump viscosity times 2, and it's red, right? And it's just kind of like a global constant that never changes in your code. And the reason it's useful is, let's say we have this bump viscosity value we want to reference everywhere in our code, and we're like, it's going to be this, it's always going to be 10, so let's just put 10 there. And then later we decide we want that to be 12, right? Or like, oh shit, I got to go and change all of those 10s to 12s. But if you have a macro, you can just go here and change it to 12, and then it automatically updates everywhere in the game. It's pretty useful. So there's a few macros we want to do. One that I like to include is a macro called isDevBuild, like that. And I'm going to set it to true. And basically what this means is this tells the game, are we, is this a dev build of the game, or is this a release, right? And the reason I do this is because I can tie a lot of like show debug messages, or some debug features like buttons or drawing something in the game. I can tie those to this macro, right? And then when we're testing it, we can use these debug features, but when we want to export it, instead of like going through the code and deleting it all, we can just change this to false, and then there you go. You won't be able to access them anymore. It's pretty useful. So I'm going to set isDevBuild to true, and we're going to have a macro called gameTitle, and it's going to be a string, project pixel, just like that. And then we're going to have a macro for the major version, 0, and a macro for the minor version, 1. So this is, version 0.1 of our game. And that's kind of useful just like, if we want to know if our game's been updated, or, what version of the game that we are currently on, if we care about certain things in the game. Those values will be largely unused, though, since we've got other version values that I'll add later for specifically like saving and stuff. The last two things we want right now is a game width and a game height. Macro game height 240. So these can be whatever you want. However, I'm going to stick with 320 by 240 for this series, and I strongly recommend you do the same. Just because if you do different values and all that, then I can't guarantee everything will work well. I will try to use these values, like use game width and game height, everywhere I need that. So like it won't break if you use a different game width and height, but you might have to tweak other values to get a better number or whatever. But also this is a pixel art game that I'm making, so small resolution. If you have HD graphics, you can make it bigger, but 320 by 240 I find is a good resolution, and it is a kind of a 4x3 like box, right? Kind of like Undertale or Deltarune or those kinds of games. If you want it to be like kind of more like widescreen, like scalable to 16 by 9, 320 by 180 is a good ratio. I'm gonna go 240 just because of the way I've got this planned and what I would like to do with this game. And those are all the macros we want right now, so I can go ahead and close this. Any further macros we can just add to this script right here. Now, quickly before we create the next thing, I want to talk about the naming convention for objects and why it's important, and naming convention for sprites and stuff. Let's say we wanted to create a object, and we wanted to call it, clock, right? We created a clock object, and we want to go to the sprites, and we also want to create a sprite called clock. It won't let me do it because the name clock is already in use, right? These are in the same kind of name pools. So how to get around that is you do spr_clock, and then the reason that we have to do obj_clock as well is because if we didn't, and then we wanted to use that name of an object as a variable, we wanted to say, let's say I have a clock and I want it to be equal to 2. Oh no, it's red because it thinks I'm talking about the object clock, and I'm clearly talking about a variable I want to set. So we want to change that to be, not edit, this is fine, obj_clock like that, so that if I want to make a variable clock, I totally can. And if I want to talk about the object clock, I can say obj_clock. So that naming convention is very important. We should keep, and it doesn't have to be this. Some people do like the letter O and then like a capital, like O clock or something like that, or like the letter S clock for sprite. But obj_ is the recommended, I believe, and it is what I like to do. That being said, forget I told you that. I mean, don't forget I told you that. But this object we're making is actually just going to be called game. And the reason for this, 1, there's no sprite attached to it, so there's no distinction there. 2, there's not going to be a variable called game in the game, so this is not a big deal. And 3, because game is going to be a very important object that exists everywhere in the game, and it's going to have some important variables. So if I ever want to reference them, instead of saying obj game dot, I can just say game dot. Game dot settings dot volume, or game dot data, or game dot flag, or like something specific, something, important value to the game. We can put in game and just call game dot to get to it, right? So I'm going to do this for some very important objects in the game. I'm just going to use, their name for them. For the ones that are around all the time, right? Most of the objects are going to use that naming convention. But the important ones, which we work with a lot early on, are going to just be that name, and that's totally okay. So we get a little object editor here. We're not going to give it a sprite. We don't need a sprite there. Don't care if it's visible or not because it doesn't have a sprite. We do want this to be persistent. And what that means, if you aren't aware, is if an object is persistent, then when you change rooms, that object comes with you. Now, a room is like one area of the game, right? So let's say you started off in a house, right? That house is a room. And then you wanted to exit the house to go to the village. The village is a different room. And you could have one room with both if you put the house like in the village and you could see the village around it or whatever. But like most games, like a Zelda game, for example, you walk into a house and now you're in a different area, a different room, right? So if this is persistent, then when we change rooms, the game, this object will come with us and keep all of its variables, which is very useful. All right, let's go ahead and add event here and hit create. These events are very nice. Basically, they trigger at different points during the game. So create happens once when this object is created for the first time. Very useful for setting up some values. The first thing I'm going to do is I'm going to type if is dev build. So we're checking to see, hey, are we in a dev build right now? And if so, do something. If not, then don't worry about it. If we are, though, we're going to type in window set caption, like that. It is, get rid of that. There we go. Which is a function that when we provide a string to it, will set the title of the window to what we provide, right? Now, by default, it's product pixel, but if it's the dev build, I want to give some more information. So I'm going to say game title plus dev build v plus string major version plus dot plus string minor version. Just like that, right? And what this is product pixel. Here, it's going to look like project pixel dev build v 0.1. That's what it's going to look like, right? And when we change the game title, if we change the game title in macros, it'll update this. If we change the major version of macros to 1.1, then there we go. Minor version, etc. So this will just set the window caption to some important information if we're, in the dev build specifically. After that, we're going to type in display set GUI size, game width, and game height. Now, this is a little complicated to explain, so I'm not going to go too far into it, but basically, if we didn't do this and we tried to resize the window a bunch of times, then the GUI might look a little weird. It might scale with the window, or it might not. I don't exactly remember exactly how it goes wrong, but I know if you don't have this line and you mess with scaling the window, then you'll run into a problem where certain GUI elements, like a dialog box or something you want to fix to the screen, appears to be the wrong size, doesn't quite appear in the same place. It's not great. But when you do this, we're explicitly telling the game that our GUI layer is going to be this size. So when we scale the rest of the game, it also has the GUI layer kind of, display properly. Now that's actually all we need for the game right now. We're going to add more things into this create event later on. But for now, we can just go ahead and close out of that. The next thing we want to do is create a little player real quick where we can move around. But we need a sprite for that first, right? We need the player to look like something. So in this sprites folder here, we can right-click, hit create, and sprite. We're going to call this spr_player. Now at this point, I'd like to tell you that in the description, there is a zip file, a link to a zip file, or a link to my website where you can download a zip file for resources for this episode, which has some sprites, some images, right, that you can drag into your game and kind of follow along with me. You're also totally welcome to create your own assets, create your own sprites, or go back and do it after you put mine in. But this is just what I'm using, I'm providing for you so that you can follow along if that is what you so choose to do. Now, that being said, in that zip file, there is a sprite called spr_square, and I'm going to be using that right now. So I'm going to drag spr_square into the game. Just drag it right onto here and hit yes. And there we go, there's a little square. So objects in GameMaker have an x and y coordinate, and this little diamond tells you where the xy coordinate will be on this object. So if it is at 0, 0, then that means that at 0, 0 is the top left corner of the sprite. If it's at 10, 10, then at 10, 10 is the top left corner of the sprite. And wherever you put this will be like kind of where it's anchored. For example, if I put it down here, at 0, 0, the sprite's going to be invisible because it will draw up and left like this way. I like to put this in the middle center, which just means that if it's at 100, 100, then 100, 100 is where this center of the sprite is, which I think is much more intuitive. Now we can go ahead and close out that sprite. That's all the information we need for the sprite, and we're going to go ahead back to objects and create a new object. And just like game, this is a very important object, so we're going to call it player. Right? Not obj player, just player, because it's a very important object. Now we're going to give it the sprite of SPR player, and we're going to set this to be persistent, just like game. And then we're going to hit add event and add a create event to this. All right. So in this create event, we're just going to have two variables set in here. We have a move speed equals 2 and a facing equals down, just like that, right? Move speed is basically how fast we want to move, right? We want to move 2 pixels per frame. And we're going at 60 frames per second. So if you multiply that, it's 120 pixels per second, which is a lot of pixels. And then facing equals down just means that we are going to be facing down. This is more visible when you've got a cooler sprite, one that has a different sprite for each direction you're facing in. But because this is just a square, we're not going to see this. But what this value is useful for is determining what direction we should look in for a sign. For example, if we hit the interact button. So keeping track of where we're facing is very useful for what's in front of us. And that's it for the create event right now. We might add some more stuff later. But we're going to add another event, and we're going to call it the step event. And the step event happens once every frame. So 60 times a second this will run. And it's very useful for game logic and moving and stuff like that. We're going to be in here for a while, so we can go ahead and hit full screen, just to kind of full screen this little window and have some more room to work with. And then I'm going to zoom in. What we're going to do is we're going to create a temporary variable called dirx. And if you're not aware, this var just means that this variable is going to be temporary, and it will go away as soon as we're done with this step event. And my little coding scheme is I put an underscore in front of temporary variables so that I know that they're temporary, and so that they don't conflict with non-temporary variables that might exist somewhere else. So dirx is going to be what direction we're going in the x direction. We can get that by saying keyboard check vk right minus keyboard check vk left. Now, keyboard check will return 0 or 1, depending on if you're pressing that key or not, or true or false, right? And if you are pressing right, it returns 1. If you're pressing left, this one returns 1. So if you're pressing neither, you get 0 minus 0, and then direction x is 0. If you're pressing right and left, you get 1 minus 1. We're not going anywhere. It's still 0, right? We're pressing them both. If you're going right but not left, it's 1 minus 0, and you get 1. And if it's not right and left, then it's 0 minus 1, so it's negative 1, right? And if you're going left, we want to move in the negative direction. If you're going right, you want to move in the positive direction. And that is because in GameMaker, 0, 0 is in the top left corner of the room, right? So going right, we increase our x-coordinate, and going down, we increase our y-coordinate. Going left, we decrease our x-coordinate, and going up, we decrease our y-coordinate. So similarly, we want to do a var dir y equals keyboard check vk down minus keyboard check vk up. Just like that, right? And there we go. Now we figured out, are we trying to go in the x direction? Are we trying to go in the y direction? Like, which directions are we trying to go? We're going to create 2 more temporary variables, one for x and y, called move x, and we're going to set it to be dirx times move speed. Same thing here, dir y times move speed, right? And this is just going to tell us we want to move two pixels in whatever direction we're trying to go in. And if this is 0, obviously it'll equal 0, right? So if it's -1, this will be -2. If it's positive, it'll be +2, and if it's 0, it'll be 0, right? So it just kind of scales up our move speed value by where we're actually trying to go. Now last we can say x plus equals move x, and y plus equals move y. Just actually go where we're trying to go. And that's it for now, but we will tweak this in just a moment, but I want to show you what this looks like. So let's take a break from player, and let's go set up our room real quick. So we go to rooms, hit room 1 right here. This is the default room that comes with the game. It's a bit big though. If we try to drag our player in here, look how small our player is. You just can't see it. So let's go ahead and fix that. So in this room width and height, we want to set this to be 320 by 240, which is the same as we put in our macros, right? Then we want to, for this grid, we want to change this grid to 16 by 16, because that is the size of our player. You can see, there we go. Player's a good size on the screen now. And let's go ahead and go to File and Preferences, and Room Editor, wherever it is, there it is. And we want to change our default room width to 320 and our default room height to 240, just so that when we make a new room, we don't have to do that every time. And then grid settings, same thing here, change that to 16 by 16 by default, just so we don't have to do that every time. All right, if we try running it now, though, we'll run into an interesting problem. The room is way too small. We can move around, though, by the way, but it's too small. So let's make it bigger. But instead of making the room bigger, we're going to just scale it up, right? And we're going to use what's called a viewport. So down here in Viewports and Cameras, we'll click this little arrow. And we want to click Enable Viewports. This is very, very important. Enable Viewports. And then under Viewport 0, we want to hit Visible. All right? If we zoom out a little bit, it's this big, giant white rectangle. This camera property we want to set to 320 by 240. That will already be set for you in a new room, but it's because this room was created with the bigger resolution. So 320 by 240. And the viewport properties, this is how big we want it to be on our screen. So 960 by 720 is what I want to use. And that is just 3 times 320 by 3 times 240, right? So it's 3 times as big. We run it now, and it should work perfectly. There we are, look at that. You can move around. There is something a little interesting going on here. We can go up, down, left, right, but if we go diagonally, we're going faster than we would be if we're going the other directions, and it's kind of noticeable. And that might be okay for you. I personally don't like it this way, so I'm going to show you how to fix that. You know, we're going faster diagonally because we're going one up and one left at the same time. Let me show you how to fix that. I'm going to open a Paint on Net, and I'm going to give you a really basic trigonometry lesson. Bring this up to 8 or something. If we're trying to go, let's say we're trying to go this way, 2 pixels, and we're trying to go this way, 2 pixels, right? Let's say this is going to take us 1 frame, and this can take us 1 frame. But if we press them both at the same time, something peculiar happens. We go in this direction, and for 1 frame, we go more pixels, because this line here is longer than both of these lines. Now, it actually is 2 times the square root of 2 is the length of this. We're moving a little bit faster when we do this. Now, how we can fix that generally is in trigonometry. Let me get the right tool here. There's a very interesting and very cool little thing, which is that for an isosceles right triangle, right angle here, and this are the same length, right? Let's say this is 8 and this is 8, or this is 10 and this is 10, or this is pi and this is pi. If the 2 legs here are the same length, then the hypotenuse here, the side opposite of the right angle, is going to be that length times the square root of 2, and this is just a nice rule, right? So what we want to do is we want to, let's say this is, I'm going to get rid of those numbers. So let's say that this down here is move x, and this over here is move y, right? And move x and move y in this case are equal, right? Or their absolute values are equal, right? So they're both 2 or -2, or one's 2, one's -2, exactly. The value of both of them are 2, right? So it applies to this rule. So whatever that movement, I'll just say move times square root of 2. I'll write it that way because that's how it works in functions, right? We want this value, but we have this value automatically because we're moving in that direction both ways, right? So we can fix that by just dividing by the square root of 2. Move it up here, and then I'll take here a little line. Take that, copy, paste. They're down here, right? And this is going to be equal to move, right? So if we're moving in both of these directions, we can divide by the square root of 2 to just get the move speed we want. So that's what we're going to do. We're going to go to player and step. And right here, what we're going to do is we want to divide by the square root of 2, but only if we're going in both directions at once, right? So this actually isn't going to work. What we have to do is we can do if dir y is not 0, then move x divided by equals, this is, this just means that equals move x divided by something. So equals move x divided by square root of 2, right? But you can just shorten this to divided by equals square root of 2 like that, right? And same thing here. If dir x is not equal to 0, move y divided by equals square root of 2. Now if we test this out real quick to show you how this works. Down, up, right. And then see, now it looks like you're going a little slower when you go diagonally. But that's because you're going the same distance, or you're going to the same speed up and down as you are going in that diagonal direction, right? So you go, so that's a more realistic movement. I like it better. Now, you can leave it like this if you want. The way I like to write it is actually a little different. It's inline. It's it's a little bit tricky, but I'll explain it. Divided by, and then in parentheses here, dir y is not equal to 0, question mark, square root of 2, colon 1. I'll delete these. And this is the same for the other one, but I changed it to dir x. So this is what's called a ternary operator, this question mark and colon. It's kind of like an if statement. All this is in parentheses, so we're dividing by something. And if dir y is not 0, then we're dividing by square root of 2. If dir y is 0, then we're dividing by 1. And same thing here, right? It's just, here's the condition, and then if the condition is true, we do this. If the condition is false, we do this. So it's just nice, one line, pretty easy. And if we run it, you can see that this works exactly the same as what happened just a minute ago. All right, off to a great start. The next thing I want to implement in this video is some collision, some basic collision. So in order to do collision, we're going to need another sprite, spr underscore mk underscore solid. And you can drag in the sprite by the same name, spr mk solid. There we are. And we're going to center this as well. Now, what mk means is it's a marker. This sprite should never appear in the game. It should just be useful for us to put over like tile sets and things to know that, hey, this is solid, you shouldn't go through it. So it's a marker, right? And this red's actually slightly transparent. You can see down there, kind of. And then we're going to go to objects. We're creating a new object, and this is going to be obj underscore mk underscore solid. All right? Same kind of naming convention. We'll get that sprite there. And that's it. That's the whole object. We can close this object. We don't need to do anything else with this object. All of the collision code is going to be in the player. So we can go to step here again. And we're just going to get rid of x plus equals move x and y plus equals move y for now. We don't want to move yet. We want to first check to make sure we can move. So we can type if place meeting x plus move x y obj mk solid, just like that. And what this means is if when this object is at this location, so where we're trying to go in the x direction and where we are at in the y direction, if this object at that location would intersect any obj mk solids, then do this. Otherwise, move on. But if it would intersect, there's a problem. We got to deal with it. We're going to start by saying move x equals round x minus x. Now, the reason we're doing this is because we're using the square root of 2 in our movement calculations, meaning that this, if we're going diagonally, this will not be an integer number. The first thing we want to do is we want to try to move to the nearest integer number so that we can do pixel calculations and get as close to that wall as we possibly can. If this is an integer number, like 3, and this, then it would just be 3 minus 3, 0. We start at 0. Cool, we're not moving. But if it's like, if x is 45.721, then round x will equal 46, and then move x will end up equaling 46 minus 45.721, which is about 0.2 279, right? So move x will be equal to that, meaning that we're going to start off by moving to that integer value, and then we're going to check there, right? So that's just kind of how it's going to work. Is we're going to round, we're going to try to make sure that we're kind of snapped back on our pixel grid when we're checking collisions. Now, we're going to check to see, we're going to do while not place meeting, x plus move x, y, obj, mk solid. That color will change to yellow in just a moment. Basically, the while loop, this will keep happening until this is false. So we're saying if we're not meeting with an object solid, like for example, if this is 0 or 1 or something, that's and when we go that 1 pixel or we stay where we are at and we're not colliding, then we want to go a little bit further. So I want to say move x plus equals dir x. And the reason we're saying plus equals dir x is because if we just did 1, then it would work if we're going right, but if we're going left, we'll be adding 1 in the wrong direction. So this is just 1, but in the correct sign, right, for the direction we're going in. So we're going to add 1 more pixel in the direction we're going in. And then once this while loop ends, that means, oh shit, we've collided. So we go ahead and correct ourselves by subtracting dir x outside of that while loop. And that means that move x should now get us to the wall and not into the wall. If we're already touching wall, move x should be 0. And then we can just do x plus equals move x, because now we can actually move there. I'm going to copy this whole thing here, paste it, and we're going to change it for y. So this is important because a lot of times programmers can make a mistake by copying things and leaving an x instead of a y. So first of all, let's go line by line. This shouldn't be x plus move x. It should be y plus move y. This should be move y equals round y minus y. And this should be not place meeting x, y plus move y. This should be move y plus equals dir y, and this should be move y minus equals dir y, and this should be y plus equals move y. And there we go. Now if we run, our movement should be unchanged, everything should be fine. But if we go into the room and we place some of these solid objects around, we can like stretch them out. Like that. I'm actually going to change this background a little bit to be just a little bit more palatable, something like that. We run the game, and now these solid objects have collision. And it was pretty easy to do. And it's super nice. You don't get stuck on the wall. You just stop moving and still move along them if you'd like to. It just works. Now, one quick thing is these solid sprites don't look very nice in this editor, and obviously they're going to be invisible in the final game. They'll be like over tiles and stuff. But I want them to look a little nicer for us, so we're going to go to Sprite MK Solid, SPR MK Solid, and we're going to do something called a 9 slice. So what a 9 slice is, I'm going to hit F12 just to get some more space here, is when we resize this, obviously it kind of stretches weirdly. So to fix that, we want to kind of break this up into 9 slices. So we're going to activate 9 slice, and we're going to drag these pink lines in just 1 pixel each, very simply, right? And now it's going to treat each of these little 9 sections differently. So these corners are going to be placed in there, right? And they're just going to be placed. They're not going to be stretched or anything. These bottom bits are going to be stretched horizontally. They can also be tiled or repeated, like tiled or mirrored, or various options. So they're going to be stretched horizontally and only horizontally. And because it is every like column of pixels the same, that's totally fine. Same here. This can be stretched vertically. This one horizontally. This one vertically, and then this middle bit will be stretched both. Or if you have a little pattern here, you can have it be tiled with repeat. But because it's a solid color, again, stretching it's totally fine. So now that we've done that, no matter how much we change the size of this thing, it'll look nice and with a proper border. Super simple. Go ahead and close that back out. If you go back to our room, you can see that they look nicer. We play the game, and it should look nicer. These solid things look a lot nicer, more palatable to look at. So that's great. Now, one more thing to address with collision is we can just like walk off the edge of the room, and I'm not a big fan of that. So instead of right now we can just walk off the side of the room, and I'm not a huge fan of that. So I'm actually going to fix that. And how I'm going to fix that is we're going to add another condition to some collisions. So in this step event again, currently we're just checking if we meet a solid object. But we're going to want to say, hey, if we're meeting a solid object, or, and this is going to be a little bit complicated, but I'll explain it in just a moment. Hit F12 to get rid of all that stuff. bbox right plus move x is greater than room width, or bbox left plus move x is less than 0. All right? So what this means is bbox right is the coordinate of the right side of our sprite. Right? That's great. And if the right side of our sprite plus where we're going is going to be greater than our room width, meaning it's going to be off the screen, then there's a collision. And same thing, if the bbox left plus move x is less than 0, it's off the left side of the screen, there's a collision. And then we got to be very careful with this one because there's a not in front. We want to surround this in parentheses, and then we want to add this exact same thing here. And the reason we want to surround it in this parenthesis here is because we want it to be, as long as there isn't any sort of collision, right? So we put them all in OR here, and then we surround it with an exclamation point, right? While not all of this, while none of these conditions are true. We can do the same thing down here. We can say OR bbox, and we can say bottom plus plus move y is greater than room height. Again, the same exact principle. Or bbox top plus move y is less than 0. Again, copy this, paste it here, but surround this in parentheses just like before. There we go. Now that's that simple. Get a little complicated, a little bit messy code, but these collisions still work, and also we can't get off the side of the screen. It's treated as a wall, so that's great. That's what I wanted to do. And that's subject to change. Maybe we want that behavior to be different later on in the game, but for now we have it. All right. Now before I let you guys go, there's one more thing I want to add into this video real quick, and that is a camera. So first I'm going to show you why the built-in GameMaker camera is bad and you should not use it. Now down here, the viewport that we're using to scale up can also be used as a camera that moves the object around. Let's go ahead and change this camera to be 160 by 120. All right, so it's half the size of before, 1/4 of the screen. If we go ahead and hit play, then what's going to happen is our camera is stuck up here, and we walk off the side of the screen. And we're still in the room, so we're not stopped. But the camera's certainly stopped, right? So how we can fix that is we can go to here, Object Following, and select Object Player. And then our horizontal border should be half of our camera width, and our vertical border should be half of our camera height. And let's go ahead and try this out, right? Let's see, then what can go wrong? Oh, God. I mean, it works, but, it's very jittery. Why is it so jittery? It's also very rigid. I don't like it. Yeah, you run into a lot of these jittery issues. You run on a lot of problems when you use the room camera when you're zoomed in and when you're scaling up and stuff. So we're not going to use it. We're going to set object following back to none, and we're going to change this back to the default. It doesn't really matter. And we're never going to touch object following again. So how we're going to get around this, we're actually going to create another object. By the way, another thing I totally forgot to do that we need to do is we take game and we need to drag it into the room. Because it didn't really matter now, it would matter later. But actually, if you noticed, yeah, I'll show you. If you notice, before we did that, we ran the game, and our caption, our window title still said Project Pixel, right? But we're in the dev build, so it should say Project Pixel dev build v0.1. And we obviously didn't use the GUI yet, so we didn't notice that was an issue, nor was there anything else the game does currently, but we want that to be in the room. We're going to create a new object. We're going to call it camera. Again, another special object. Doesn't say obj underscore, it's just going to be very special, so camera. And we're going to make the camera persistent as well. And we're going to go to variable definitions. This is a little new area. We're going to hit add, and we're going to type in move speed, set to 1/10, and add this one, and we call following player. Now basically what this does is, if I go to a create event here, this is basically the same thing as just writing move speed equals 1/10, and following equals player. This is basically the same thing. It's just creating these variables and setting them to these values. But the reason it's so useful is because now if we go into a room and we throw in the camera and we double click on this little thing and hit variables, we can actually override these. Like, let's say we want this camera to be 2/80, or that, I don't know, that's 1/40, but like, you can change this to whatever you want, or pi, or whatever you want. 3.14, 1/15, right? And you can hit this minus button to restore to default. Or if you don't want the camera to follow somebody, you can set this to no one, right? Or undefined, or whatever we decide, right? Yeah, basically variables that we can change very easily from instance to instance. And then in the create event here, we want to type in x2 is equal to x and y2 equals y. These are just two more variables. We don't want them to be in here because we don't want to like be able to change them per instance. And then that's actually it for the create events. We're going to add a step event to this as well. And basically, we're going to check if we're following someone. So if following is not equal to no one yet, we use no one, it looks like, right? No one's a keyword that, I don't know what the value it has, but basically it tells GameMaker that this is not an asset. And this usually should only be used when you're referring to an asset. Like if your sprite is no one, then you don't have a sprite. If the object you're following is no one, then there's not an object that you're following, right? So if the following is not no one, then we're following someone, and we want to try to go to the object we're following. So we're going to use your big functions here. I'm going to full screen this real quick and hit F12. x2 equals following.x minus camera get view width view camera 0/2. Okay. Basically, following to x, this is going to be player, basically the player's x coordinate right now. But if we wanted to follow like a different character for a cutscene, or we wanted to follow, whatever, right? Then whatever that is the x. We're going to the x coordinate, but we're subtracting the width of the camera over 2, right? Basically, the width of the camera is, what we can see on the screen, the width of what we can see on the screen. And then that divided by 2 is half of what we're seeing on the screen. So if we want our player to be centered, then we want to subtract half what we're going to see on the screen to get the left bound of our camera. So x2 is our left bound of where we want to go. In fact, x and y of the camera is going to be the top left corner of our view, right? So the same thing with y2. We want following.y minus camera get view height view camera 0/2. And view camera 0, by the way, is just means that we're talking about view 0 here, viewport 0, rather than viewport 1, 2, 3, 4. These are useful in some games when you have like a local multiplayer and you want to maybe like a split screen multiplayer where you want to show 2 different areas of the world at the same time. But we are only using one camera in this game, so view camera 0 is that. And then I'll ignore the problem with this, and then I'll come back to it once I show that to you. Now we want to say x plus equals x2 minus x times move speed. I'll explain this in just a second. Y plus equals y2 minus y times move speed. And the reason we're doing that is because we're trying to figure out how far we need to go. Let's say we're 10 pixels away, and then multiplying by 1/10, we're moving 1 pixel. 9 pixels away, moving by 1/10, we get 9/10, or moving 9/10 of a pixel, right? So this kind of gets like this effect where we go faster the farther the camera is away, and slower when we get close to our destination. So it's kind of a more smooth camera movement. And then we want to say camera set view position view camera 0 x, y. Because without this, we would be moving the camera object, but it wouldn't actually be moving our view. So this is just updating our view position, which is this x position, y position. We're moving that to the x, y coordinate of the camera. Go ahead and let's throw, or the camera's already in there. Let's go ahead and hit play and see what happens. Nice, it's working. Now let me show, first of all, look how smooth that is. I love it. You can tweak some numbers. I'll actually show you some differences in the move speed. But I love it. The problem with it is, why can't I go any further? And I actually have reached the edge of the room, but we haven't stopped the camera from moving. So even though I'm at the edge of the room, we can still see beyond the edge of the room. So we want to add a couple more lines, 2 more lines to our camera. in this if following is not no one. And we want to say x2 is equal to clamp x2 0 room width minus camera get view width. I have this spaced out. That view camera 0. And y2 is equal to clamp y2 0 room height minus camera get view height view camera, keep misspelling camera 0, just like that, right? Now what clamp means is clamp is a function that sets y2 to be whatever's in here, but if this is less than 0, set it to 0. If it's greater than room height minus this, then set it to that, right? So it kind of gives a minimum and a maximum value that it can have. We're clamping it between these two values. If it's between those values, it's fine. It's just y2. But if it's less than 0, or if it's greater than room width minus the camera get view width, and that's because we want it to be in the left side and the top side, right? So one view width, one view height away from the room width and height. Then we set it to those. So when we run the game now, that problem's fixed. We can go up to the edge of the screen, and then once we get halfway down the screen, the camera starts moving again, and then it stops, and it feels a lot more natural. Look at that. Let's go ahead and go to room, and I'm going to show you the airplane going by. Let's go to the camera and variables, and let's change this to 1, for example, just 1. And what this is going to move precisely like this. This is kind of like the built-in Game Maker camera, except for there's no jitter, right? I mean, there's a little bit of a bounce that's not great, but it's generally fine, right? But it's very lifeless. It's not great, not my favorite thing. Let's try 1/5, something a little more subtle than 1/10. Yeah, this is fine. Much faster paced camera movement. Still a little bit of subtle, like stop and then the camera catches up. But it's pretty nice. If we can do 1/15 and make it even more exaggerated than our default, you can get like pretty far on the screen before the camera catches up to you. Yeah, and you can mess around the number, put it whatever you want. It won't break anything else in this game, so you set that to be what you want it to be. I like 1/10, which is why it's my default value. There you go. And you can always change these numbers or what it's following for very specific points in your game. If you want it to like generally be 1/10, but sometimes 1/5 or sometimes 1/20 or whatever. But yeah, that's the camera. And I think that's actually all we need this episode. We've done a lot. We've kind of started our game. We've added some variables. We've created a player we can move around and a nice camera and some basic collision. We've done a lot for today, actually. So be proud of that. So the last thing I want to do is just kind of commit our changes, right? We've done a lot. I don't want to lose it. So let's close out the window. Let's go to Git real quick. I'll go ahead and clear that. We're going to type in Git status, and you can see, oh, look at all this stuff. There's a room. There's like some options files, objects. A bunch of stuff has changed. Let's go ahead and add all of this stuff. Git add -- all, just like that. And then git commit -m. We're going to say episode 1 : implemented here. Let's say added player movement, collision, and a camera. That's a pretty good summary. Hit enter. And then that's a lot of files that were added. Let's go ahead and push that. And then check out our GitHub page, make sure everything's good. Yeah, there we go. We got our episode 1 commit. And we can see everything we've done. Look at all this shit that we've done. You can even see some of the files that we don't like have exact access to, you know. Default script type, I think, is whether we use code or visual or whatever. All of the stuff we've added. Pretty cool. Changed 23 files. You can see it's mostly Yak, a little bit of Game Maker language. But yeah, there we are. That's our project. And obviously linked to this version of the repository in the description if you want to go check out that code if something's not working for you and you want to compare specifically. With that being said, I will thank you guys so much for watching. If you don't want to miss these in the future, please subscribe and like this video if you enjoyed it. And I'll see you guys next time.